down, and before you give presentation, our head of study program will give a speech. Are you okay with that?
Yes, of course.
Oh, okay. And this webinar will be guided first by MC, and then it gives to me, Metanis Savitri, as moderator for your presentation later.
Yeah, okay.
And this webinar will be um held in 14 p.m. in this time area, and maybe we wait 4 minutes again. How about that?
Yes, of course.
Okay, thank you, Dr. Osians Aken. And is it my pronunciation of your name is correct? May I address
Yes, you
you
can call me Ozgenç.
Osgens?
Ozgenç. Yes,
Osgens.
Ozgenç.
Okay.
Yes, Ozgenç, yes.
Osgens. Okay, thank you.
Yeah, no worry, no problem for me.
Okay. Yeah. Maybe we wait for the MC to open this webinar. Okay, thank you, Dr. Osian.
Yes, thank you. I will be there in a minute, okay? May I share my screen?
Yes.
Hello, Mr. Osian. Maybe you can share your screen after the Master of Ceremony give this webinar to me, and then I'll let you share the screen. How about that?
I couldn't hear, sorry.
Oh, okay, okay.
You can see the screen, right? You can see the presentation right now.
Yeah, yeah. Oh, this, yeah, I can see it.
Okay, okay.
Yeah. But maybe you can start your presentation after speech from our head of study program. Are you okay
Yes,
with
of
that?
course.
Oh, yeah, okay, okay.
Yeah.
Maybe it's already 14 p.m. and the master ceremony can open this webinar.
It's now 2 p.m. We will begin the webinar. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. First of all, let us thank God for His blessing so that we can take part in this webinar in good condition. I would like to welcome all participants to our webinar entitled Soil Characterization in Landslide-Prone Areas Using Surface Wave Methods. Today, we are honored to have our speaker, Assistant Professor Özgen Akın from Karadeniz Technical University, Turkey. Before we begin, I am Kiano and I will guide you through today's agenda. Next, we will listen to the opening remarks from the coordinator of Geophysical Engineering Program to the respected Bapak Purwaditya Nugraha SSIMT. Please, the screen is yours.
Okay, before we begin, do you hear my sound, MC?
Yes, I can hear.
Okay, I will start. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon to all audience in Indonesia and good morning, Professor Özgen Akın. In Turkey,
Good
I think
morning.
it's still morning right now.
Yes, 10 p.m.
Okay.
right now.
Okay, thanks. First of all, we give thanks to God Almighty because thanks of Him we can gather here to discuss about soil identification using surface wave method. And to honorable to our speaker today, Professor Özgen Akins, we will share about soil identification using surface wave method because as we know in Indonesia, surface wave method is one of rapidly development geophysical method than other geophysical method because surface wave method is can available to applied in various field in earth science like geotechnic, shallow subsurface identification, and like what you will share about soil identification. So I think your knowledge shared to us is very useful because the surface method is very various method in Indonesia. And to honorable the Geophysical Engineering Study Program to attend this event, and to honorable to all committee who have made this event is conducted, and to all my students in Geophysical Engineering Study Program who have give their time to attend this event. I think it's a rare event. We can invite the other speaker from other country. I hope you can take all benefit right now to take opportunity to know the knowledge from the other speaker. First of all, I would like to thank you to Professor Özgen Akins. I'm sorry if I didn't spelling well your name. To share
No
your
worry, it's
knowledge.
okay.
Okay, to share your knowledge in to us here because I think surface method is very useful for us. And I hope you can present it and explain your presentation with slowly because as we know, every student in Indonesia is not good to hear in English. So I hope you can be slowly to presentation and explain your presentation. And the second, I hope the student who attending this event, you can take all benefit, give the question to Professor Özgen Akins, and be curious because your curious will guide you to take the knowledge and take the opportunity to speak with the other English to other speaker. And the last, if don't be afraid to take a question because you can if you can speak in English, I think you can speak in Indonesia to the moderator and the moderator will translate your question from Indonesia to English so the speaker will explain your question very well. I think it's enough for me from me. Enjoy the event, enjoy the seminar, enjoy the discussion. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you for the warm remarks from Bapak Purwaditya Nugraha. Now we move to the main session. I would like to invite the moderator to introduce our speaker and lead this main session. To the moderator, please, the screen is yours.
Okay, thank you, MC. Good afternoon, everyone. And good morning for Mr. Oskens. How are you today, Mr.?
Hello, good morning. I'm fine. First of all, I would like to thank you for this kind invitation. Hello from Turkey. Selamünaleyküm.
Waalaikumsalam.
Waalaikumsalam. And myself, Metani Srina Savitri, will serve as moderator for this session. And please allow me to explain about our agenda. We have two agendas, 40 minutes presentation and followed by 20 minutes discussion and Q&A session. And allow me to introduce our presenter. Our presenter is Dr. Oskens Aken, who is an assistant professor from Karadeniz Technical University, Turkey. Dr. Oskens Aken research specializing in engineering geophysics, near-surface geophysical investigation, geotechnical site characterization, and landslide hazard assessment. His research also focuses on the application of surface wave methods and other geophysical techniques to investigate subsurface conditions to improve the understanding of geological hazard. And for the Q&A session, if you would like to ask questions during Q&A session, please use raise hand feature and I will allow you to ask directly to the presenter, or you can type your question in the chat box. Additionally, if you have question or confirmation while presentation is still running, please write it or type it in the chat box and I will deliver it to the presenter in Q&A session. Without further ado, I invite Dr. Oskens Aken to deliver today's presentation. The time is yours.
Okay, thank you very much. I will share my screen for my presentation. Okay, I think you can see the presentation, right?
Yes, I can see it.
Yeah. Okay. Thank you very much. As you said, I am Özgen Çakın from Turkey, Karadeniz Technical University. First of all, I would like to thank you again for this invitation, and also I would like to thank to Dr. Handoyo, who is we met in Barcelona, and thanks to him, I met the ITERA, ITERA family, and I am very happy to be here. Today I will talk about an investigation on the landslide prone area by especially using surface wave methods. In the first part, I will summarize the study. In the second part, I will try to introduce the study area. And by the way, I would like to mention about the methods briefly because I believe there are undergraduate students among the attendants, as far as I know. And finally, I will share the results with you. Please don't hesitate to ask question to me. And after that, after the question, also we may discuss about the potential project or studies or research, something like that. I would like to introduce the study. In Turkey, especially, you may know that the region is so actively according to aspect of the earthquakes. But the main problem for us, especially in the East Black Sea region, is landslide. It is the most common disaster in the Black Sea region because we have steep slopes and the heavily rainfall precipitation. So we can easily say that the study area is located one of the most dangerous, hazardous area in Turkey in the aspect of landslides. You can see in the figure A, Trabzon, where the study area is located here in the Trabzon province, you can see the color is quite red. That means the distribution of the landslides events is very high. Also, we can say that is the highest one. And as we can see the landslides victim by the province, the Trabzon province is the highest one again. And also Maçka is close to Trabzon, is a district, one of the most dangerous places in the Turkey, and the study area is located between Trabzon and Maçka. Also, I'd like to mention about the main factors. As I said, we have steep slopes, climatic condition, and moreover, we have earthquakes and the human-induced activities, such as uncontrolled excavation and insufficient engineering practice in this area. We investigate this area because the area is approximately 10 kilometers away the Trabzon center, where 500,000 people live there. It's a quite big city for us. And in the study area, directly study area, more than 10,000 people live there. As I said before, the main problem is the paleo and the active landslides in this area. Both at the large scale. That's why we collected in situ geophysical measurements to determine and to characterize the study area. So the main aim is the study is characterize the soil for the study area, and the other aim is demonstrate the effectiveness of the ground shear strain parameter, which I will explain later, in detecting landslides. For this purpose, we used both active and passive surface wave methods, which are HVSR, SSR, as you can see on the left, RWE, and MSW. The first three one is the passive source methods, and the last one, MSW, is the active source method, as you know. If you talk about student area, there are lots of landslides, as you can see in the figure. The red lines show the active, still active landslides here, and the navy blue shows the paleo landslides here. As I said before, it's so close to the city center, and the lots of landslides, many landslides are located at the east side of the study area. I would like to mention about the earthquake hazard of Turkey. As you can see, the study area is located on the coast. Trabzon is so close to Georgia. You can see the maximum PGA is approximately 0.2. But it's defined after 2018. Before this, it was 0.1. After that, what happened in the 2018? There are lots of fault systems in the Black Sea, and that's why they are all calculated with the hazards, and the maximum PGA is getting 0.2 from 0.1. That's why PGA may not seem very high, considering that existing building stock was designed based to value 0.1. That's why it's doubled. It's so major change, we think. That's why we choose this area. As I said before, Turkey is so active region seismically. So we have lots of tectonics units, and the Trabzon and the study area is located at the, as you can see in the figure, the eastern pointed orogenic belt. and is divided into 3 subunits: northern zone, southern zone, and the axial zone. Moreover, Trabzon is surrounded by all the fault system, and especially you may know the North Anatolian fault system is so close us. It's approximately 100-150 kilometers away from the Trabzon. This fault zone can produce large size and the big size earthquake, such as Erzincan 7.9, Tokat 7, and again Erzincan 6.8, such as these. We think that these kind of earthquakes may trigger the landslides. That's why we have to investigate the soil characterization, and of course we use the geophysical method in situ measurements, something like that. The geology, there are 4 main formations, as you can see in the figure: Çağlayan Formation, Tonya Formation, Kabaköy Formation, and the Quaternary alluvium. And we are, I can say that we are lucky in the Black Sea region because the bedrock depth is not so deeper. It's shallow. It's changed to maybe 15 meter to 100 meter. That's why we can see the outcrops from basalts. We can easily see some outcrops in the area. As I said before, I would like to mention briefly. Please, if you have a question about the methods, feel free to ask me. Firstly, we use the MassW method. We collect the MassW profiles at 20 points. You can see in the figure A the raw data, and after that we transform data, phase velocity, and the frequency graphic, and we pick the maximum amplitude. And if we color the B1, we can get the C. You can easily see the fundamental mode. It's also known that there are lots of modes at the MassW method. Higher modes also are here, and we use the fundamental mode because we want to investigate shallower and the deeper parts of the area. That's why we choose the fundamental mode, and the minimum frequency is approximately 5.4 frequency. The minimum frequency is 5.4, I think. In the figure D, you can see the dispersion curve, measured one, from the data. And after defining the initial model, we calculate the dispersion curve, and we are trying to matching them like this by iteration, of course. And finally, we get the 1D VS model at the figure F. You can see the best matching is give us the best model. And another method is it's a well-known method, HVSR, also known as a Nakamura method. It's a microtremor, is single station microtremor method. I'll try to explain briefly. As you know, rail waves constitute the microtremors, so we can easily see that the deep sourced effect can be omitted. That's why it's a simple ratio. When we see the figure, we ratio to VS to VB and HS to HB. But if we say that the deep sourced effect can be omitted, the final equation is like this: horizontal to vertical, horizontal to vertical. You can see on the left A, the windowing the data. Each color is correspond to each graphic in here, spectras, amplitude spectras here for vertical, north, south, and the east, west. These are frequency spectra. And finally, after the ratio, by the way, firstly, we have to calculate the one horizontal like this one. This is, it's Turkish, sorry, not kg, it's NS, and the other one is not dB, it's EW. So we are calculating to horizontal to get the one horizontal, and after that we ratioed horizontal to vertical, and in the figure C you can see the ratio, and the final graphics gives us the predominant frequency. As you can see, the maximum peak shows us the predominant frequency is 8.3, and the HV ratio, which is not represent the real amplitude, how can I say, is amplitude. That's not the amplitude, it's a kind of ratio, and we think that it's useless parameters. That's why we used another method. This method, standard spectral ratio. There are advantage and the disadvantage in this method, because if you want to use this method, you have to has a rock outcrop. So as I said before, we are very lucky in this region. We can see lots of rock outcrop in this region. But if you don't have outcrop, you can't use this method. In this method, measurements are taken in the both alluvium and the rock, as you can see, and after that the horizontal components ratioed each other. This challenge of this method, as I said before, if you don't have an outcrop, you can't use or benefit from this method. We use this method because we want to get the real amplitude. And as I said before, I want to say again and again, HV ratio is not a amplitude. So we use the Rayleigh wave inversion because we want to increase the investigation depth. As you know, MSW method is limited up to 30 meters if you are lucky. That's why we want to go deeper. We use the Rayleigh wave inversion. In this method, the FX HV waves on the horizontal component need to be removed with the continuous wavelet transform and the Morlet wavelet, and the inversion performed by attempting to ally the calculation curve by obtaining the HV curve. As you can see at the on the left, on the right, figure A. After getting the HV graphic, we calculated the ellipticity, and it should be matching to each other. And after, you can see in the figure B, we use the mass W dispersion, because if you don't have a mass dispersion, the initial model can be a little bit challenging and not reliable. That's why we use the mass W dispersion and the RWE, I mean the Rayleigh wave immersion method together. We use the joint immersion. And finally, we get the 1D VS model, but the difference is that we get the VS model by the mass W up to 30 meters, but in the joint immersion, we can get deeper, and up to 100 meters we can get the VS model. The study area, And you can see all the measurements here. And as I said before, there are lots of landslides. The navy blue one is the active, and the white ones is the passive, not passive, sorry, paleohalas here, paleo landslides here. Sorry, I can confuse sometimes. And you can see the red dots here. Red dots represent the HVSR methods and points, and the red squares shows the reference microtremor points where we can see the outcrops here, especially basalt sourced, and the white squares show the mass W and the RW points. And finally we get some cross section, but I want to use my time, how can I say, I want to use my time logically. That's why I won't talk about this cross section. One of the parameters is predominant period. You can see the predominant periods on the above obtained by HVSR method, and below you can see the SSR method. Both method is microtremor method, and they give us the reliable predominant period results, and you can easily understand they are same. You can see the higher predominant periods on the landslides area, like this, and the of course like this. I mean, the 1.3 is correspond to on the landslides area, but the light blue one, the 0.1, correspond to the other parts of the area, which are no landslides here. So we can easily say that they are matching each other, and the two methods are reliable. But the problem is here, we think, and the literature think that, because we would like to compare all the application calculation here for this area. I mean, the A1 HVSR ratio, it's not amplitude. SSR, it's a real amplitude, we think, and the empirical ones, which is Midorikawa and the Bochert, C and D respectively. As you can see in the figure A, you can easily aware of the landslides, but the maximum value is not matching with the landslides. I mean, this area on the east side, the orange one shows the 5 to 6 amplitude, but there are no landslides here, and I will share later, the VS30 value is getting higher in this area. But on the other hand, when you see the SSR, which is real amplitude, is directly matching with the landslides area, which means the 6 and 5 values corresponds to landslides area. As you can see here, is a there's a landslides, and there are some landslides also here. That's better, and that's logical, we think. And after that, as you can see, as you know, the empirical equation doesn't match every area of the world, but we just used to get a ratio. As you can see, the ratio, amplitude ratio, according to Midorikawa, is matching with the landslides here, but the ratio is less than 3. But we know that according to VS value, it should be higher. That's why we can easily say that Midorikawa and Bochart is giving us a real application, but it's a kind of just a ratio, not a real, how can I say, not a real exact number. That's why if you are lucky and if you have outcrops like this, you can easily use SSR ratio method and get the real amplitude. Yes, I also mentioned about it. The VS30. VS30 is obtained by MassW and the RWE method, and we get 20 profiles, and finally we get the model like this. You can see the north here, and you can see the A, B, C, D. These shows us the other aspects of the area. I mean, this A1 is like this. The north is here, and in the B, north is here, and the C, north is here, and the north is on the here. This is the front, this is the rear. You can easily aware of the whale geometry here, and as you can see on the legend, the VS parameter changed between 230 to 1430 meter per second. In this area, as I mentioned before, this VS30 value is more than 500. That's why the amplification according to HVSR shouldn't be 6 or 5. You can see VS30 values distribution here. The lowest values correspond to landslide area, and the highest one is the no landslide area, non-landslide prone area. So according to VS30 value, we can class easily the area like this, soil classification. You can see the darker one and the gray. You can see the soil class here, D, according to this one, C according to Eurocode 8, and the ZD according to Turkish build and earthquake classification. Sorry, the other one. The darker one is the low one. The lighter gray is the higher one. The best, not best, it's better soil according to these classifications. So we can say that the landslide area class is not good according to other ones. Non-landslide area is better than this landslide area. And finally, we calculate the ground shear strain. This parameter is very useful, I think, if you are trying to define the, how can I say, the landslide limits and the, how can I say, the border of the landslides. You can use the ground shear strain parameters, which we can calculate with amplification square, predominant frequency, PGA value, and the bedrock VS value. This PGA value obtained from the Turkish building and the earthquake paper. I mean, according to DD2, that means probability of the existence of 10% in 50 years. We get all the PJ value, and as you know, we get the amplification value from SSR, and we also get the predominant period, HVSR or SSR, it doesn't matter, they are matching. And by using MassW and the RWC, we get the VS value for bedrock. That means if you are talking about this kind of small values, it can be dangerous. It can be loose, and it should be taken into consideration. That's why, especially in this area, in the landslides area, if these values is higher, the soil is looser, as I said before. The GSS values calculated by this equation. And the conclusion, I don't want to take up your time by going all over the results again. So I can briefly summarize them as I said before. In this study, we use active and passive sources, which are HVSR, SSR, RWE, and MassW, and we use sometimes joint inversion to investigate deeper. And we obtained the final result GSS parameter. GSS parameter is very important for us because we can easily define the landslides border according to this parameters, and also predominant periods and the VS30 values are so important for us to understand the soil classification and the soil characterization, because if we class the soil, we can easily define the planning area. I mean, for the building, we can easily plan the area. That's why these parameters are so important, I think. These kind of studies, I think, is a crucial thing for the especially seismically active areas. That's why we use in-situ measurements here. And yes, that's all. I can say that's all. If you have questions, please don't hesitate to ask me. And thank you very much.
Thank you very much, Dr. Oskens, for the informative and insightful presentation. From
Thank you.
today's presentation, we learned some surface wave method from Dr. Oskens, such as SVSR, SSR, and MASW to analyze landslide hazard potential. We will now move to the question and answer session. To ensure that we have enough time for discussion, we will use a question collection system, Dr. Oskens. Participants are invited to submit their questions through the chat box or use raise hand feature. Question will be collected in group of 3 questions per round, and after each round, the presenter will address all 3 questions before we move to the next round. And now, please raise your hand or submit your question through the chat box for audience. Maybe while we waiting for question from the audience, I would like to ask question to you first, Dr.
Of course.
Oskens. Yeah, okay. Your presentation is very interesting, and lately, our student favorite methods for undergraduate final project is HVSR method. And for HVSR analysis, students mostly analyze general HVSR parameters such as dominant frequency, and then amplification factor, and seismic vulnerability index. Hello, Dr. Oskens. Sorry for the technical problem. Hello, committee.
Hello.
Oh, okay. Sorry for the
I think we are all
technical
here. No
problem.
problem. I think.
Okay. Maybe I'll repeat my questions. Yeah, lately our student paper method for undergraduate final project is SVSR method, but
Sorry, I couldn't hear you. Sorry. Can you please?
okay. Do you hear my voice clearly now?
Yes, I am trying to. Yeah.
Maybe please wait a second.
As I
will
understand, you have
setting.
2 students, and they
Yeah.
are working on HVSR, right?
Yeah, right.
Yeah.
And the analysis is just a general HVSR parameters such as dominant frequency, amplification factor, and seismic vulnerability index, or maybe using inversion method for gaining 1D PS profile. But in your presentation, you said that P ratio is not representing real amplification, so we cannot use amplification factor in this case. So do you have any suggestion how we accommodate calculating amplification without using amplification factor from SVSR method?
Yes, you're right. There, the HV ratio doesn't reflect the real amplification factor, because according to microtremor, as you know, the source of the microtremor is so changing. I mean, the deeper and the far away, it's not defining from us. That's why if you have our outcrop like this, like in Trabzon, in study area, I think this is the best way to get amplification. But if you don't have, you can use the VS values. But the important thing is that you have to investigate up to bedrock. If you, how can I say? If we can investigate up to, for example, 20 meters and the bedrock at 50 meters, so it doesn't show the real amplification. That's why the best way is the SSR and the real earthquake records. If you have some deployment, loss of station already ready, you can use them. But if you don't have, the SSR is the best way, I think.
So it's okay to just use inversion method to get VS 1D VS profile without amplification factor, something like that. And when I listen to your presentation, I also I also understand that SSR method can get the more proper amplification than SVSR, but in SSR we must find the bedrock first, right? The outcrop of bedrock. So for the acquisition process, we deploy the seismometer in the sediment area, and then we deploy it on the outcrop of bedrock, something like that, and then we make ratio of that.
We ratioed H to H.
Yeah.
We don't use the V1. I mean the Z1, vertical one.
Oh,
If
the vertical one
you
is the vertical one is for the sedimentary area or all of the area?
No, all of the area. If you use the ratio between two stations, not in one stations, if you use the two stations, also we can use in the buildings like this. You already may know. I don't know. I just want to say, if you are measuring some microtremors in the building, we don't use the V component, the Z component, because according to Nakamura, we accept that the microtremors consist 80% from rail waves, but the rail waves amplitude is getting decreased deeper when we are getting deeper. That's why we use the just H ratio to H ratio in building and also alluvium and the outcrop.
Oh, okay, so we use a horizontal component for SSR method, right?
Yes,
Dr.
yes,
Osken?
right.
Okay, thank you.
By the way, I
for-
want to
yeah.
add something. SSR and the HVSR both gives us the reliable predominant period or frequency. It's no arguable. It's okay for us.
So the arguable one is the amplification from
Yes.
H and HV ratio, right?
Yes,
Yeah.
yes, you're right.
I read some scientific article. They also say that the amplification factor or the ratio of H and V method is not really reliable and not representing the amplification of our site area, something like that. And
Yes. By the way, I have to say something about this. If you are working on KG, I mean the vulnerability index. Generally, in the literature, the researcher use the HV ratios, but I think the ratio it shouldn't be HV ratio. If you have a chance to get the real amplification factor from SR earthquake records or the MSW or the joint immersion by the MSW, with the RWE. You can use for vulnerability index by using the real one. And also I can give some references about this. It's not only just my opinion, but I am looking for. I am sorry, I am not read about it, but I am trying to find this. There are lots of study about the HV that says it doesn't reflect the real amplitude.
Yeah, there is maybe my last question about ground shear strain, GSS.
Yes, of course.
In the GSS, we use amplification. So the amplification is the real amplification from SSR, not from SVSR method. Is it right?
Yes, SSR.
Professor?
Yes, you're right.
Ah. So the
It's
KG
better.
is
If you have a chance, it's better.
okay.
HV ratio generally doesn't use for anything, I think. It just give us an opinion, but sometimes this opinion is not right.
Okay. And then oh yeah, that's my last question. I guess I give opportunity for others.
Yeah, no
Okay.
problem. Don't hesitate. Thank you.
Okay. Maybe other audience would like to ask question. Please raise your hand. Okay. Pak Purwaditya, please ask your question.
Okay, thanks moderator Miss Meta. And thanks for Professor Oskin Akin to share your knowledge to us here. I think it's interesting presentation. As we know,
Thank you
the
too.
how HVRR method can be applied in a lot of country. Especially in Indonesia, we have thick sediment and a lot of rock outcrop. Like you say before that, if we haven't the rock outcrop, the HVSR is not have the opportunity. So my question is continue from the discuss with Miss Meta. What the role of the rock outcrop to interpretation the HVSR data? Because from HVSR we can only get the
Could you
amplification.
please repeat it the last sentences? Sorry.
Okay. What the
The
role of
HVSR?
what the role of rock outcrop to HVSR interpretation? Because the HVSR data we only get the amplification and natural frequency. So what the role of the rock outcrop and what happen if we haven't and we can find the rock outcrop? What the effect to the interpretation data? I think it's that my question. Can you understand?
Okay. I understand. I
Yeah.
will try to explain, but firstly, I want to share something. Sorry, I am just looking for a paper.
Yeah, you explained before that if we cannot find the rock outcrop, we can take the benefit from HVSR. So what the role of the rock outcrop? I just curious from that.
Yes, I completely understand that. I am looking for a paper. Sorry. Yes, this one. Sorry. Do you see the figure?
Yes, of course. I can see
Yes.
you present the paper, right?
Yes.
Yeah, of course. I can see your.
It's Turkish, sorry, but I will try to explain it. According to Nakamura, if we are measuring on the bedrock, the amplitude factor doesn't change, and it's approximately 1,
constant,
as you can see. Because the main knowledge is that Microtremors consist from railways, and the railways amplitudes going decrease by the dip. That's why it's a kind of acceptance, I think. If we are talking about the bedrock, we can easily say that this is a real application factor. But as we all know this, the ground is not homogeneous. That's why we can not accept for the each point. That's why if you are using the HVSR, we have to be careful about it. But as I said before, I should say that according to predominant frequency or period, it's completely reliable. It's no problem for us.
Okay, thanks. I can
It's
understand.
okay for you?
Okay. But what we have to do if we cannot find the rock outcrop in the study area? Like example, in
Yes.
Indonesia, lot area is closed by the thick sediment. It's hard to
Yes.
find the outcrop. What happened to what we have to do so we
Yes,
can
you're
the
right.
correct interpretation?
Yeah, there are lots of valley in Turkey too. For example, maybe 500 meters, even if 800 meters deployment we have. In this situation, we have to use a deeper investigation, such as SPAC method, spatial autocorrelation method, or if you have already deployment stations, for example, earthquake stations or like this, we can measure long data, and after this we can calculate the amplification factor. But the main point is that you have to reach to bedrock depth, because we are calculating the soil amplification. That's why we need the bedrock first to define
Okay.
the soil.
Okay. So to correct interpretation, we still need the supporting data to know the rock outcrop, right?
Yes.
Okay. I think it's enough. Thank you, Professor
Yeah,
Oskin.
thank you.
Okay, thank you, Pak Purwa. Maybe next question from our lecturer college. This is his question.
I'm sorry,
He would
Miss
like-
Meta.
Yeah.
I'm thankful for I'm sorry, Mr. Professor Oskins. I have to leave right now because I have to attend the
No
thesis
problem.
defense right now.
Yeah, thank you so much. Thank you for your
Thank
kind
you very much.
invitation. Thank you so much.
Thank you very much, Prof. Oskins. I hope we can meet together and meet
Yeah, I hope
directly,
to.
not by online.
Yes.
I hope. Yeah, thanks very much.
Thank you. Bye.
Okay, we continue to the next question. This is the question from our college in study program, and he would like to ask about GSS for identifying landslides. Can GSS values be validated using deformation data from GNSS or satellite data?
Sorry, are we talking about the text message right now?
Yeah.
Yes.
Yeah, text message. Yeah,
Okay.
he sent the question through message.
Yes, I saw. I am sorry. Sometimes I couldn't hear you very well. That's why I just want to read it.
Okay. Maybe I repeat the questions.
Okay. The first question for the mixed soil classification. Of course, this kind of studies should be should be getting further. I mean, if you are talking about a building, the area of the building is so important for us, and this kind of studies, we can easily say that this studies is kind of microzonation. But specifically, if we are building some structure, we have to investigate going further. And if we are do this, the soil classification is getting one, not mixed one. And they also explained that amplification according to shouldn't be 5 or 6 because of more higher than. Yes, could you elaborate on why higher, what leads to lower expected? Of course, if we are talking about the VS30, as you know, we use the VS30 values for the classification. It shows is the soil loose or massive. That's why we can easily say that the 500 meters per second is quite high. That means the lower parts is more than maybe 700 meter per second. That means as we can understand that generally the 760 meter per second is correspond to bedrock. That's why this VS30 value is quite high, and we don't expect that the 5 or 6 times bigger amplitude hitting to building or shaking the area. Am I clear?
Maybe Richard Asidik can respond. Hello.
Yes. Alright, I apologize for asking my question.
Or maybe we process to the next question.
Yes, next question. Your study shows the SSR method is much more accurate than HVS of this area. As a general lesson, should geophysicists avoid using only HVSR when mapping landslide hazards and the other area with some characteristics? Yes. I mean, HVSR is a reliable method, but just for predominant period or predominant frequency. If you are working on a landslide area, you can use the HVSR, but the selecting of the HVSR point is so important. If you don't know the landslide border, you have to do some research, pre-research, to define the HVSR, or you can just start the HVSR, and according to the results you can get many data additionally. That's why we can use HVSR, but especially in the landslide area, I think, according to me, I think we need the VS30 value. And of course, if we are talking about direct landslides, we have to do some electrical measurements. But my presentation is not directly with the landslides. I mean, of course, there are lots of landslides in this study, but my aim was the microzonation and defining some landslides areas border. If we are talking about investigate the one landslides, we have to use the electrical methods. It's very important. If my preferences direct influence both of soil class and also. Yeah, thank you so much. Yes, thank you so much.
Okay, maybe the next question is from my lecturer colleague, Dr. Oskens. He sent
Okay.
me a message and I will read it to you.
Okay.
He would like to ask about the GSS for identifying landslides. And can GSS values be validated using deformation data from GNSS or satellite data?
Honestly, I don't have any information with the satellite data. Of course, there are lots of satellite data in this study area too. But if we are talking about a small area, this satellite data, I mean the raster-based data, it doesn't match for the geophysical data. Because the raster dimension is so important. If you are using 100 to 100 square, it changes. Or you can use 20 to 20 square raster data. It changed. That's why as I said before, we have lots of satellite data, but if we are talking about the in-situ data, sometimes it's quite challenging to use both of them.
Okay. On the next question. Oh, this is there is response from Haura Fadiah Nuis. So for landslide area mapping, electrical measurements need to be carried out.
Yes, it's definite.
Okay.
Yes, it's definite, and it's needed.
Okay, maybe another questions. Oh yeah, Mr. Oskens Eken, for our next agenda after this webinar. Maybe before we plan to discuss about our next project, something like that
Yes.
with our study program. But unfortunately, our head of study program has other agenda. Maybe I will confirm first from Pak Erlangga. Hello, Pak Erlangga. Pak Erlangga is head of our
Okay.
research group.
Okay. Mbak Meta, I'm sorry, I'm currently walking to GK 2. I need a time to to settle my laptop first. Sorry.
Oh, okay. There's also a chat. Oh, okay.
Also, we may arrange another meeting for discuss the
Okay.
potential collaborations. I am ready for that. For no problem. And I am ready, and my department is ready for that, and we are happy to be here.
Okay. I guess there isn't any question again, and once again, thank you, everyone who submitted questions and participated in this webinar discussion. And thank you, Dr. Oskens Aken, for sharing your expertise and for addressing our questions so truly. And I pass this webinar to the Master of Ceremony.
Yeah, thank you so much. Terima kasih.
Yeah.
Sorry.
Sama-sama, yeah.
Terima kasih. Thank you for your invitation and for all the attendees. Thank you so much.
Yeah, you're welcome.
What a wonderful presentation. I would like to extend my sincere appreciation to Assistant Professor Özgen Akın for the insightful and inspiring presentation. Before we proceed, the closing session, we would like to present the certificate of appreciation to our speaker, Assistant Professor Özgen Akın, for sharing his valuable knowledge and insight in today's webinar. Please allow us a moment to display the certificate.
Yes, thank you so much.
Thank you, Assistant Professor Osgen Akin.
Thank you, terima kasih.
Thank you for your contribution and participation in this webinar.
Yeah, thank you so much.
The discussion session has ended. Thank you to all the enthusiastic participants. Before we get to the closing, I remind the participant to fill in the attendance sheet first. We have reached the end of webinar today. I would like to say thank you once again to Assistant Professor Osgen Akin for the insightful and useful, interesting presentation. And also thank you to all participants for your attention and participation. We hope this webinar is useful for all of us. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon.
Waalaikumsalam warahmatullahi
Good afternoon.
Sorry. Before we end the session, we will take a documentation. Please, to all participants, turn on your camera. Ready? 1, 2, 3. Once again. 1, 2, 3. Okay, the last one. 1, 2, 3. Okay, thank you. For the participant may leave this webinar. Thank you to all the participants for your participation in this webinar. Okay. Next, there will be a discussion session with the lecturers. Lecturers are welcome to join the breakout room. Thank you.
Thank you. Greetings to Indonesia. Bye-bye.
Bye.
Hello again. I'm here.